player performed relative to those projections. Okay. Now, then there's f of v1, which is the scaled value of the best move. And similarly, there's f of vi and f of vj. Okay, these are scaled values of other moves. Okay. Now, so relative to the overall intellectual discussion in the world of chess programming, this is what Stockfish and other traditional chess programs use. Okay? They use the raw values. Okay? Actually, I should specify that what they use just the raw values of the moves. Now, the other thing that's involved is E of V1 and E of VI. This is the expectation value. So the expectation of the best move. In other words, the position on the hole. Okay. And this is the expectation after playing, expectation if you played move MI instead. Okay. Now, this is what alpha 0 uses. Okay. Problem, EB depends on B, which depends on the rating. Okay, so this is what I've been calling the sliding scale problem. And maybe we should fix the B that goes with a player rated 2,000, or maybe we should fix the B that goes with a player rated 1,500. Okay. You've actually been seeing one of those fixed Bs and the fixed A and other logistic curve parameters that go with it. The reason why alpha 0 could afford this is that it ratcheted up its own B in the games against itself. Okay, so it altered B on the fly during the process of its training. Okay. And this, then, which is what I actually have been using, this is a non-sliding scale compromise. Okay, with a particular scaling function. So those are the quantities to fit on, and then there are some other ones that my current model currently has not been acting on directly at all. Okay, so there are 5 of those, and the first one is whether the move drops a positive eval to 0. Actually, drops a positive eval to 0, in other words, losing the advantage. So this is VI equals 0.0. Okay. Then there's whether the position value 0. Okay, so that's V1 equals 0.00. And then there's both of the above. And what's going on there is a very fine point. Now, I told you this is different from the issue of a tied optimal move. There also seems to be some weirdness with a tied optimal move at 0. Basically because chess programs can be very forgiving of mistakes if those mistakes leave a 0 value. Okay, so this is just Vi equals 0.00 and V1 equals 0.00. Okay. Then there's whether the move turns advantage into disadvantage. So whether it goes all the way through 0, okay, and that's V1 greater than 0 and Vi less than 0. And there's whether the position is worse as disadvantage. Okay, and that's just V1 less than 0. In other words, does all the action take place in the minus portion of the eval? And in general, the mathematical reason for this is we're using the idea of the value of a position. Okay, so x equals, so this is the value. Okay, so minus 3, minus 2, minus 1, 0, 1, 2, 3. A lot of the mathematical functions that we're using are defined only for v greater than 0, like ones involving logarithms. Most in particular, we might want to define square root of v. So let's say we have v to the 1 to the 0.5 power. Okay, well that's a nice. I mean, that's what the square root of function looks like. Okay, but it's not. It's imaginary for negative numbers. Okay, so therefore, what we might want to define instead is we might want to define the function the sine of v times the absolute value of b raised to the 0.5. Okay. Now, if we do this, this is the negative respecting power or mirror respecting power. Okay. Then what we get, we'll get a negative value, but we get something like this. Okay. It's actually now continuous at 0. It doesn't go undefined. And it produces an overall effect that's an S-curve. It's not a logistic curve because it is unbounded, but at least it's nice at an S-curve. But the general point of having these extra terms is that we want the general value of having these extra terms is that weird things are happening near 0. And I've uncovered enough examples in my research to know I have to do something about it. So we're going to have parameters that reflect these terms. Okay, so now, okay, so the model that you've been using and that I've been using for 7 years, so the previous one, model, was taking, okay, taking the scaled delta. So it was 1 over s multiplying f of v1 minus f of vi. Okay. And then raising this to the power of c. And this was fed into 1 over e to the x, I'll say. Okay. So this is xi, okay, which I'm defining to be that, was fed into the inverse exponential curve. And then this produced ui, and then we finally have pi probability being p1 to the 1 over ui. Which, by the way, notice there are two inversions of this. So this is really p1 to the e to the xi, okay, by itself. Okay, and if you, so there's one aspect of riding a tiger here, okay, and this, the fact that my model has been successful in the past tells me the tiger is there. The tiger is the use of exponentiation. We're taking our basic chess values, and we have a linear expression in them. First, we're raising those to the c power. Okay, c, as you may have noticed, usually is pretty close to 0.5. It's a little under, a little over. Okay, so it's fairly close to taking a square root. And generally speaking, since v1 is the best move, this was always positive, and we were sort of using the positive part of the square root function. But with swing, with these, with the, so new terms I haven't written on the board yet, we might get negative values. So, so hence the liberalization of the square root function. By the way, that's one level of exponentiation, although it's really a square root. So, not too bad. But we're exponentiating this e to the xi, and then we're exponentiating again with the probability. So this is 2 or 3 levels of exponentiation outside the realm of a linear regression. Nevertheless, I have rejiggered my model to try to make it understandable to us, me included, and, as much as possible as a linear regression. Okay, so that's the old equation for xi. Okay, so the new is going to be xi equals, well, I'm going to be optimistic and say that this is under the join policy, and say that xi is going to be the sum of 3 terms, t1 plus t2, I'll circle that though, plus t3, okay, raised to the c power. Okay. And this, what this is going to represent is an adjusted perceived relative value of mi. Okay. That's the whole idea of the and this xi is defined to be a perceived inferiority. So xi means inferiority, ui means share of optimality. Okay. Then from the shares of optimality, we infer our probabilities. Okay, so that's the conceptual way things are going. Okay. Now, so it's going to be these 3 terms, of which T2 is the swing term, and I'm going to pretend that that this swing term T2 does not exist to keep things simpler. Okay. So now these are our quantities, and I've named parameters that go with them. And you're going to help me, however, make 2 executive decisions on how I should represent the equation. Okay. So this, by the way, this is a new parameter called TZ for to 0, FZ for from 0, BZ for both 0, This is SF for sign flip. And this is NE for negative eval. Then the S parameter has been rechristened as multiplying that. This now is a parameter called R. This is a parameter called Q, and this is a parameter called P. And this one is a parameter called T, and that one's governed by a parameter called U. Okay. So now the expressions I'm trying to fit are, term one is PV1 plus QVI, okay, plus R F of V1 plus S F of VI, okay, plus U E B of V1 plus T times EB of V1 plus U times EB of VI. Okay, for each move I. And actually the I is called J in the code. Partly because I wanted to reserve I for the played move, but I'll call it I here. Okay, so that's term one. And term three, I'm pretending that term two does not exist for a moment. That's just going to be TZ times this event VI equals 0 plus FC times V1 equals 0. Okay, plus BZ times both plus SF times V1 greater than 0 and VI less than 0 plus NE times V1 less than 0. Okay. So that's really intended to be a correction. Okay. Now, so now let me now call this 0, S0 for the old S. So now here's the new model equation. So let's look at what the old model had. Okay, so the old model had, okay, well, in terms of this new equation, it has S equal to 1 over S0, okay, but with a minus sign, and it has R equal to, because that's that's subtracted off, 1 over S0. Okay. So in particular, it has it forces S equal minus R. So R equals minus S. Okay. So in other words, the old model was working off the difference of these two terms. And it was not, it had P equals Q equals T equals U equals 0. And the other term 0 is 2. Okay. So that's my old model. Now, there is there are two temptations here. So one of them, the first question is, should T1 have minus S times F of VI and minus Q times VI minus U times EB of VI. I'm sorry, actually, yeah, EB of that's the first question. And the second question is, should these quantities P, Q, R, S, T, U be divisibles? Okay. So these are the main discussion questions. Now the reason why I might want to do this, so this is what I'll put in blue, is that I have an alternative form of T1, which the code allows. So this is decouple, and this is couple. So there's an option for that. And I can make this P of V1 plus Q times the difference V1 minus VI. I keep R times F of V1, but make this S times the difference F of V1 minus F of VI. Okay. And also keep this as T times EB of V1, but make this U times the difference, EB of V1 minus EB of VI. Okay? So the point is that we have a parameter that is covering the difference in value, what you lose by playing the move. Here directly, what chance of winning the game you lose by playing an inferior move. Mathematically, these are equivalent. Okay, it's just the same actually as, well, what it is the same as is the same as flipping the sign of S, because S is now multiplying a minus term, and it's replacing this blue R is now the old black R plus the old black X plus the black S. Okay. So I have coded the blue alternative as well, because that's actually closest to what my model had. Now, so my model is the blue alternative, which kind of takes care of the first question, but then with the second question with S flipped upside down. Okay. So, let me put these out there. So one question is, so now this is, what this is doing is this is trying to write the fitting of my model as close to a linear regression as possible. And in a linear regression, when you don't know anything about the coefficients that you're fitting, that you're solving for, you have no right to make any assumptions about sign. And you really should just leave them as positive multipliers, and don't use any mathematics that will break if one of the numbers turns out to be negative. Okay? And to tell you the truth, in this term T3, I haven't even done this. I just programmed this. I've been wanting to do this for a long time. I had other means of trying to handle these ideas. So I have no idea whether from the actual data that we're getting, whether these numbers are going to come out positive or negative. So I'm just going to write them with plus signs. But up here, I do have some idea that the Q should be positive, okay? Or here, the S actually should be positive. The Q, by the way, is what you get in my current model if you don't scale. Okay, so I should say, so S becomes, so Q and S So S becomes Q if you don't scale. So in my program, okay, so I'm going to take the very trepidatious step of code compiled just 20 minutes before class. Actually, I even made a nominal change to it. I'm not even going to compile it. This one. Okay. So this thing may segfault for all I know, but hopefully it won't. Okay. I have some idea that so S becomes Q if you don't scale. So I have the option when you define things, go into fixed settings here. Okay, you apply yes to the reference trial, and -2 to define a new scale. And these are the settings, so you can do no scaling or linear scale, which is almost the same thing. There are some differences with how it treats high value and low value moves. And then there's these various other kinds of scaling, of which the simple one has worked. And as I told you before, there's this other option of what to do about tied moves. Now, in my new program, I've put the default that I am allowing swing of moves. So I am therefore enabling the term T2. Right, but I have the swing multiplier set to be 0. Now there's a lot of other stuff here. I don't expect you to understand it because, in fact, I don't even understand it. But what it was trying to do, it was trying to handle issues that I'm now just letting be handled by the regression. So in particular, for negative, there was a separate negative gradient factor that would enable me to handle moves with a negative evaluation differently. Okay, came from observations of some of the figures that I've actually shown you. Okay, so this is, but the main thing is that with the new, instead of forcing you to make this upfront choice of whether to scale or not, so whether to work with the V1 or VI, instead I'll allow you to have one function f, and you can combine it in the terms as you wish. Okay, so all right, so let's actually all right, so let's do 6.5 AA 1800 in what year was it? 2016. Star KOM 10 star AIF. Okay, let's load that. I think that's the one we did last time. And now let me be brave and just go into the run fit. By the way, the version of IR that you have, I have not yet put this out for you. But you'll notice right away that instead of just one line printing 8 parameters, now there are 3 lines printing lots of them. And if I go in here, now instead of seeing 8 options to set bounds for, you see all the ones, still including D and V, but you see all the ones divided into these categories. Okay. I'm actually going to turn swing off. So the way I can turn swing off is I can just give it bounds of 0. So there are 2, I can turn it off in the policy or I can turn it off in the fit. And I can turn off the A thing by making it just have the value 1, so neutral value. The same way B has a neutral value. Okay, so here we go. And so now I'm fitting 2 equations and 2 unknowns. And pardon me, I've never run this before. It's probably going to say false, but let's just give it a try. AA 1800 in 21.6, KOM 11 with 2, and with KOM 10 with 2. And also with a sense of S being inverted. All right, so let's see what happens. Okay, well actually it hasn't segfaulted so far. Wow, okay. So let's see, but we got S equals 9, all right? In fact, it's actually fitting reasonably well. And we got S equals 9. And in fact, I may have been the dummy because I may have not have changed the bounds of S because I'm so used to S being inverted. Okay, So, oh, I started with s equals 20, actually. And then, so it made this. Now, the c has a value near 0.5, as we've been pretty used to. But instead of the s being around 0.1, s is now inverted. It's 9. But we did get a good fit. And there it is, 43.67, fitting that. Not fitting that terribly well. This is just awful. 0.1 is just awful as an index fit. But that fit. This is horrible. And these are also horrible. All right. So one little issue is that, well, okay, let me start putting up some pros and cons of this. Okay. So I'll get rid of, oh, I'm going to keep that whole model. Okay. All right, so the question is, first of all, should we use the sign? In other words, I have the idea that with the defaults, what I was doing was I had the terms coupled. So I was using T1. Okay, so in the, right, I meant to show this. Actually, I probably have it in my scroll bag. Okay, let's see. Actually, no, we've had to, where is that? No, I have to, that's very in the menus. Let's go take a look. 2. Yes, -2. Okay, so now we take a look at the swing policy. It has it here. Oh, actually, I've taken off the default, but it was actually coupled. Okay, all right. No, that's not what I had to do. Okay. All right, so but the fact that I got a nice S value means they must have been coupled. Otherwise, I would have gotten nonsense. I would have gotten a negative value. So it was, in fact, multiplying this with the negative sign. Okay, so since I'm expecting the multiplier of S on Fi to be negative here, should I legislate that the sign of this thing is minus? Okay, so should I insist that my linear regression equation is written with a minus sign because I do have some idea of the values of the parameters? Okay, so I want S greater than 0 as a quality measure. Okay. And then using S, say equal to 9.6, it makes more is better. Okay. Versus using 1 over S, so it would have gotten 0.11, something like that, means lower is better. Okay, so that's a public relations issue. If I want S to be a quality measure, sensitivity. If it's lower, that means you're more sensitive. In the original way I thought of the model. But 1 over S, not S, has strong linear relation to the ELO rating. Okay. So if I do that, then so the alternative. So do I want to legislate in the code that T1 is 1 over P, 1 over P V1, minus 1 over Q VI, plus 1 over R F of V1. Oh, sorry. Actually, if I do both options, then what I would get is it would get plus 1 over Q, well, I'll leave it like this, minus 1 over Q VI, plus 1 over R F of V1, minus 1 over S F of VI. Okay. Do I want that? Or do I want it as 1 over P1 V1 plus 1 over Q V1 minus VI plus 1 over R F of VI, V1 rather, plus 1 over S F of V1 minus F of VI. Okay, and this is what I've always been calling delta I. All right, so that's the question. What form of the term? Should I keep it linear? Should I legislate minus sign? Should I keep it uncoupled with plus signs, the simplest way, the way I'm doing T3? Or should I legislate minus signs for the Q and S? Should I invert S? Well, if I invert S, I should probably invert all of them. What to do? So, some reactions. So first of all, how many think I should have the terms on VI, the ith move be negative, the negative sign? What's that?
I don't think it's true. You mentioned earlier about something about coefficient that you should make it to not be
What's
negative.
that?
You expressed earlier about the coefficient, that how you should not consider that as a beginning, as
I should not.
consider that as a minus sign.
Yeah.
So
In other words, be agnostic about what the coefficient might mean.
Mm-hmm.
Only thing is, I'm pretty sure it's going to come out negative. So do I want to tell chess players in the world that they have negative sensitivity?
Mm.
Do people like negative numbers? Okay. Yeah. All right. You ready?
I mean, you can just call it like invert or negative sensitivity, or you could just basically, I don't know, change it to Z and then just say S is minus Z. There you go. That's your sensitivity rating.
I could do that. I could have another. That's true. Now this would solve a problem. So one moral thing is, if I decided that I wanted to print the negative sensitivity, I'd have to write minus S everywhere in the code.
Mm.
But instead, I can make a new, different variable. I could call it NS, assign it to minus S once, and print NS everywhere, the official sensitivity value. How many people like that idea? So it's another moving part. That's the only thing. And in fact, it's the desire not to have multiple moving parts. Well, okay, so that's the minus sign issue. Now, how about the coupling issue? So should I write the top equation in blue instead, where I have my Q and my S and my U multiplying differences rather than multiplying the raw quantities?
Mm.
Seems a little simpler just to do a dot product for the decoupled one in code. Just it'll vectorize a bit.
And in
It's
fact,
one less operation.
yep, and in fact, she said a very important thing. She said dot product. Okay,
Mhm.
so a lot of these of the utilities that I might be interfacing this program with in the future, assume that you're taking dot products of vectors. So I have to expressly alter the vector to say f of v1 minus f of vi. And in point of fact, that's how I started doing it. I call that the delta. So in the code, you'll see that there's a separate delta, p-scale deltas, and then I get the scaled evaluations, the f of vi. I actually compute f of v1 minus the delta to get f of vi. It's a little bit, yeah, obviously I'll optimize the code later when I'm happy with it. So yeah, okay. Anyone else about whether I should, right now I have it as a user selectable option. And I think it'll be interesting for us to see if it causes different dynamics in the fitting process. Anyone have someone from the background, what would you do? All right. How many in the back row prefer to keep one separate term for each raw quantity? How many prefer the opposite? Oh, I'm not getting, wow, okay. Not getting any opinions here. Okay.
So,
Yeah.
so, but actually, how much of an impact does the difference play? And if we were to replace just the simple difference by some other loss function between the V1 and VI, would that make a difference?
I don't know. I just programmed this at 2 in the morning last night. But it is a great team project idea. So this was, by the way, supposed to be the week before spring break, and this was supposed to be my finishing the advertisements of team project ideas. But for various reasons, things got. I was supposed to do this in January, and things came up. Yeah, so that's a great question. And now, with what I'll give you over the weekend, you'll have the opportunity to investigate it. I actually don't know. As I said, one reason I don't know is that although this is a linear regression, it's riding inside 2 levels of exponentiation in a very chaotic process that nevertheless seems to correspond closest to reality of when people play chess, at least in terms of what I've done to date. Now, how about the inversion issue? So this, I think, is one where there are 2 reasons for thinking that I should invert, but then I'll tell you why I'm reluctant to. Okay, so the 2 reasons why I should invert is 1, V1, VI, and the F of them. Those are dimensioned quantities. They're units of value, units of centipoints. In economic terms, they're dollars. Okay, and I want to manipulate dimensionless quantities. Okay. Well, physics even plays tricks with that notion. But ideally, thinking as a purist, I want to divide out those units, and I want my parameters, though, I want my sensitivity to have those units. I'm saying sensitive to small changes in the value of a position, sensitive to whatever fraction of a pawn. So I want sensitivity to be denominated in pawns. That's how chess players think, okay, rather than in inverse pawns. Okay, but to do that, I have to invert the variable s in my equation. Now, yes, I could take the 9 that printed out when I did this run, and then make my ns be the -1 over it, and maybe that's what I'll wind up doing. It's naturally, it's more natural to have it as a divisor. just like when you do acceleration, your time is a divisor. Okay. Now, okay. Then the second reason is that what you've seen in the graphs you did, or most of you did, it's the 1 over S, the 1 over form that has a strong relation to ELO. When I graph S versus ELO instead, I get a curve, hyperbolic curve. Okay, so I get a nice, so something is telling me that my sensitivity parameter is in a strong linear relationship to skill in chess when it's inverted, and maybe not otherwise. C parameter I'm less sure of, but so then there's also a third reason, although maybe the third reason isn't so important, and this has to do with numerical variation and precision. By keeping S inverted, I keep it in a nice little box between 0 and 0.4. Okay, and the C, as you know, is a nice little box between 0.4 and 0.6 for the most part. Whereas if I use S as a multiplier, then it'll have values like 9, but if the S is 0.05 for the world champion, that's going to be 20. And it's sort of gonna extend the scale. Now maybe I really actually do want that. That would be like saying, the world champion's twice as sensitive as an 1800 player. That might have some benefit to it. But the meaning of the numerical perturbations when you have a number that is up near 20 is a lot different from the meaning when the number you're dealing with is stepping near 0.1 or 0.2. And this matters to simulated annealing, and it matters to regressions using the GNU scientific library. So this, again, is a real project thing, okay? So what actually happens, though, is the GNU scientific library transforms whatever parameters I give it anyway. And it's doing that probably for the same numerically beneficial reason. So ultimately, it may not matter to the precision of what you're getting, but it would be a great project topic to try the equation both ways, and I can add an invert option. I might do that. So there's all these reasons why I feel inversion is right, but there's one reason why I don't. And this is simply that what I actually think is going to be useful and needed, okay, is what I hunch. My hunch is that all of this work, and this is something maybe I could have done, is that instead of scaling, all I really needed was this. I just needed to instead of scaling for the evaluation of position in advance, I should have let it be part of the regression. So I have a hunch that what I'm going to wind up doing is I'm going to be doing P.V1 plus 1 over S0 f of V1 minus f of Vi. Okay, and this whole, and either this thing separately or inside raised to the C power, or maybe kept separate. In other words, oh, and plus the other stuff, plus TZ dot the other stuff, adjustments near 0. Okay, I have the feeling that maybe most of my ills can be solved by just keeping the evaluation of the position around as a term. But if I'm doing that, then, and if I'm using V1 for other purposes, then maybe I don't want to invert P. But inverting S and not inverting P is inconsistent. So, so that's where it's an issue. But anyway, so this is the last thing that I would propose as a project, and before you judge it, please do read my comment on page 6 and 7. So that's for reading over the weekend. And then, since I finished this long coding scheme, I will finally be in touch with you guys about what you're interested in doing for the rest of the term. But this is ending what I intended to come with. Anything more now, I'm intending to be just practical experiments. Okay, all right. Any questions? And feel welcome to give me feedback or post on Piazza. Maybe I'll make this put a Piazza post with just this, and this can prompt you guys to react. And also let me know if you've had this kind of design consideration with regressions you've seen in textbook. I mean, ultimately it doesn't matter. You could do any of these forms and get values. There's a one-to-one correspondence of the solution. You'll get values. But the form matters to the public interpretation of what you're getting, and maybe more importantly, the form may also matter to the nonlinear dynamics and the other issues of fitting the model that I've encountered. Okay.